Plasma Rotating Electrode Process, which is also known as the PREP. So what is happening in this process? So in this arrangement, you have a fixed tungsten electrode, and then you have a rotating alloy bar from which you want to extract or you want to produce your powder, and this is also rotated at very high speed, and then it is brought near to this tungsten electrode tip, and a potential is applied which causes the generation of the arc or the plasma in between this the intergap between the electrode, and this plasma or the arc causes the melting of the consumable electrode, because your tungsten will not be consumed. It will have high melting point. It has a high melting point, so it will not consume easily. But with the course of time, with longer duration, this will also start to degrade or erode from the tungsten tip, and then it will also cause the contamination of the powder particles in the powder producing through this process. So you have a consumable electrode, rotating electrode. Now this arc is causing the melting of the surface, and also this this consumable bar is rotating. So the powder particles, the liquid metal which is developed at the surface, it will experience the centrifugal force. So again, the centrifugal force will cause the atomization of the powder particles, and this process is carried out in a very specialized, you can say, the setup, and this is also relatively maintained at low temperature, and gas purging is there, and the unwanted gases are sucked up with the help of a vacuum pump, and you get high purity, low oxygen contained titanium alloys and super alloys. So titanium alloys and super alloys are of you can say the high melting point. So that this plasma generated at the surface can easily melt these materials, and they will easily be converted into powder form. And however, there is a large size range. 50 to 400 micron size is the large size range which you have obtained in this case. Okay, and as I've told you that tungsten contamination from the stationary electrode is a limitation. So with the course of time, this tungsten electrode will also start to degrade and erode, and they will the fragments from the surface, it will mix with the powders particle which are generating on the surface of a rotating consumable electrode. Now this process is we have already discussed. This is a mechanical communition or the pulverization. So as you can see here in this figure, we have a large cylindrical vessel which is rotated with the help of a motor mechanism, and this large cylinder rotates about its axis, and from one end what you do, you fill the charge. Charge is basically your big powder lumps which you have extracted from some surface, from some can say some source, or from the chemical reduction, you have obtained the big masses and lumps of the powder material, and then you fill this with the rotating cylinder with the help of a steel balls. So the steel balls will also rotate along with the rotation of this cylinder, and then the steel ball will impact on the surface of this powder particle, and it will cause the breaking of the solid particle due to brittle fracture. So this process is particularly used for those materials which are brittle and less ductile. Okay. Then we'll discuss about the mixing of these powder particles, different metallic powders. So once you have the powders in your hand, the next step is to mix the powders. If you want to make an alloy composition, and if you want to make some ceramic composition, then you need to mix all these powders thoroughly, because for achieving the good compaction, sintering, and good mechanical properties, these metallic powders must be thoroughly homogenized. Okay, otherwise what will happen? So that at a particular location in the mass, it will have different material composition, so it will have different mechanical property, so and different location and different configuration, you will have different material properties, so it will cause a non-uniform material property in the product, and it will cause the premature failure of the product under the actual working condition. Okay, so now we have the process of mixing. So you have two terms. Generally, you have two terms, and those are used against each other. And sometimes you are confused that what is blending actually, what is mixing actually. So both the function is same, to produce to effect the uniform mass, to generate the proper mixing, but however, the blending is referred that condition when the powder of the same chemical composition are mixed, but they have different particle size. And in case of mixing you have powders of different chemistries, and they are mixed with each other with the help of different mixing devices. So you have mainly for the industrial application, industrial mixing, you have four types of configuration. The first one is the simple rotating drum, which we have already seen in the mechanical pulverization, mechanical communication. Then we have the rotating double cone arrangement. Third one is your screw mixture type. Then you see here in this case, then there is a cylinder which has a screw which is rotated at its own axis, and it causes the mixing and the blending of the powder material of your choice. And the third case is your the blade type of mixture. So these four type of configurations are used for your application, and all have different you can say the performance and the purity, or you can say the quality of the mixing, and all are of different price range. So the screw type will be the much costly as compared to the rotating drum type or rotating double cone type arrangement. While discussing the basic steps of powder metallurgy, in the first step, when you have the powders in your hand, and the first step is this, to blend or mix all the powder particles thoroughly into each other. And for this, what is the process? This is called the mixing process, and we use containers, and you can see the mixers which we have already seen in the previous slide. So what is the thumb rule? The thumb rule are is that you don't fill the containers completely. So there should be some enough space in the containers, and most of the times these containers are made 20 to 40% full of the total capacity. So in order to give the space for the powder particles to rotate and to intermingle with each other. And during this blending and mixing process, certain additives or raw materials are added, which helps in the whole manufacturing process. So the first ingredient or the raw material which is added along with the feedstock powder is the lubricant. So we have different types of lubricants, and generally the stearates of zinc and aluminium are added in small amount, and these are available in basically in the powder form, and it will have some soapy touch, some greasy touch, and they are mixed along with the powders to be mixed. And what it does, it reduces the friction between the particles and at the die wall during the compaction. So I have told you that what is the effect of the friction in the powder particle. So it will help in easily the flowability. It increases the flowability in the die cavity. And also during the compaction process, there always a very small clear gap between the die and the punch. And there some automatic arrangement, automatic lubrication is always required to reduce the wear and tear of the die and punch. So this solid type of lubricant is the preferred one, and the zinc stearate and the aluminum stearates are the top choice. And we have some binders. Binders we are used to required in some cases, not always in all cases, to achieve adequate strength in the presses, but before the unsintered part. So just before the sintering part, what happens that whatever the binder you add into the powders, it will be burned off. It will be liberated into the in the sintering step. So you select the binder that it causes the, you can say, improvement in the green density. So green density is the density that is obtained after the compaction but before the sintering process. So it should improve the green density, but it should be volatile in nature. It should be it should be of that material which should be it should be easily liberated during the sintering process. Then the third ingredient we use is the deflocculants. So what it does, it inhibits the agglomeration of the powders for the better flowability characteristics during the subsequent processing. And certain additives like allignates we use, and these are of aluminium and sodium salts of alliginic acids, and it serves at three functions such as the deflocculant, suspension agent, and binding agent to improve the green strength of the compact. So all these four ingredients are used to improve the flowability, to improve the agglomeration of the powder, to improve the flowability, to improve the green density, and to reduce the friction between the particle and the die and the punch cavity. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.